Right. So now let's look at question number 14, part B of the pure mathematics paper. Right. This is the application of differentiation. Right. So this figure is given to us, a wedge consisting of two identical plane faces OAB and DCE. So this angle is also alpha then. These are all radiuses. Right. This is height and this is height. Right. Then which are sectors of circle with radius r with sector angle alpha. The three edges OD, then BE and AC are all perpendicular to both faces, giving the solid appearance as shown in the figure with thickness h. Given that the volume of the cheese wedge is 9, so volume is 9. Show that the surface area of the wedge is given by this. So we have to find the expression for the surface area. So first let's write a expression for the volume. So volume is what? Cross section area times height. Cross section area is this one. This is your cross section, right? So this sector part is your cross section. Then that into what? That into height is the volume. So cross section area is what? Half radius squared into the angle, which is alpha, times height h. So that is going to be equal to 9. So then r squared alpha h is equal to 18. So let's look at this expression. We want doesn't have h, no, so we'll subject h from here. H is what? 18 over r squared alpha, right? That is our first equation, right? So then let's find a expression for the surface area. So it has two of these sectors. So s equals 2 times half r squared alpha plus it has what? Two of these rectangular faces which are h times r. These two, h times r. So that gives you 2 times r into h plus this one. We have to find the surface area of this forward facing surface. So then we have to figure out what? This length, and think of this as approximately as a rectangle and do it. This length we know, no? This is the arc length, which is what? R alpha. So we'll write this as this forward facing surface as h into r alpha. So that. So now simplify. So s equals r squared alpha. Okay, that we want 2rh r alpha h. So then replace h. Sub 1 into 2. You get what? S equals r squared alpha plus 2r 18 over r squared alpha plus r alpha 18 over r squared alpha, right? So then simplify and look at the answer and simplify, then it is easy. R squared alpha term we already have. Other two terms have been combined using r alpha as the common denominator. So I will just cut r here, leave the alpha here. So then because these two terms both are combined into a single term by using common denominator r alpha. So I will just cut r from here, not cut alpha. Then write what is left and you will get the answer when you simplify it. S equals r squared alpha 36 over r alpha plus 18 alpha over r alpha. Combine the last two terms and take the common term out, which is 18. So 2 is left from the first one, alpha is left from the second one, right? So that is the expression we wanted, right? So that is done. Then we want to differentiate that with respect to r. So find the derivative with respect to r. So 2r alpha. Here this whole thing 18 plus 2 alpha over alpha, that whole thing is what? That whole thing is a constant. So instead of r, think of this as r to the minus 1. Then you can apply the formula, no? So minus 1 r minus 2. So what is the derivative then? 2r alpha 18 times 2 plus alpha minus, no, minus sign is there, so minus alpha r square, right? So that's the derivative. So what's next? Hence find r such that area S is a minimum for alpha equals 1 radian. So take alpha as 1. Take alpha as 1. So then 2r minus 18 over minus 18 times 3 r squared. So this is ds over dr. So when alpha equals 1 radians, find r such that area S is minimum. So let's find the stationary point. So equal this to 0. ds over dr has to be equal to 0. So that means 2r is equal to 54 r squared. So that means r cube is equal to 27. So r has to be 3. So now let's check whether this is a minimum at r equals 3. 0, 3, ds over dr sign. Let's check. Let me check r equals 1 as my test value here and r equals 5 as test value here in the second interval. So substitute r equals 1. What do you get? 2 minus 54. So that is minus. This is minus. Then I took r equals 5. So then what do you get? 10 minus 54 over 25. Yes, that is positive, no? So the sign is positive. Minus positive means decreasing, increasing. So yes, it's a minimum at r equals 3. So then do we need to find the minimum value of, hence find r such that area S is a minimum for, hence find r such that the area S is minimum, right? We only need to find the r value. They haven't asked us to find S. If you want, you can find S also easily. Just substitute what? Alpha equals 1 and r equals 3 here. But that is not required. So therefore, we'll write the concluding statement. Therefore, S is minimized at r equals 3. Right. So that is the answer for 14 part B. Right. Then we'll do the integration question 15.